Hello everyone, welcome to this video lecture series of design of steel structure on the platform of AKtU digital education. In this lecture, we will talk about the various loads and their combinations which we use for the design of any steel structure. Now, in this lecture, we will cover our discussion into following points. First, we will discuss about the various loads which we use or which we consider for the designing of any steel structure. We will discuss about dead load, imposed load, wind load, earthquake load, erection load and thermal effects in the loads section, loads category. Okay. Then in the later part of this section of this lecture, we will talk about the various load combination which we should consider for the designing of any steel structure. Okay. So, now let us talk about various loads. First is dead load. What is dead load? When we listen dead load, what comes into my mind? What comes into our mind? Our mind says that it is that kind of a load which is dead in nature. What does it mean? It means it is a kind of a permanent in nature. More specifically, it is the weight of all the permanent construction or all the permanent sections used in the steel structure or any structure. Okay. For example, if it is a house, okay, let me just show you. Okay. So, the weight of this beam, the weight of this slab will comes under the category of dead load. Our IS code says in the clause number 3.2.1.1 that dead load should be assumed in design as specified in IS 875 part 1. IS 875 part 1 is also a IS code entirely dedicated for the calculation, for the consideration of the dead loads of various construction material available. Okay. Now, let us talk about the imposed load. What is imposed load? Okay. So, as we listen the word imposed load, it what comes in our mind? Our mind says that it is kind of a occupant kind of a load, okay, that is imposed on any structure. Okay. For example, let us look at our same building again, and if there is a boy standing on this structure, then the weight of the boy will be come in the imposed load. Okay. Some people say it is a live load, okay, and imposed load is a bigger domain and live load is a subset of it. Okay. Imposed load, then some would say that imposed load must consider other kind of a load. What kind of other load comes into the imposed load? So, our IS code says in the clause number 3.2.1.2 that it includes live load, crane load, snow load, dust load, wave load, earth pressure, etc. Okay. So, etc. means there are other kind of a load which comes in the imposed load. We must think what kind of a loading which is coming on the structure and what is its nature. Is it its nature is of permanent or temporary or occupant type of a or imposed kind of a, then it will lie in the imposed load category. Okay. So, as there is a dedicated code for the dead load also. So, dead load there is also a dedicated code for the imposed load also. It is IS 875 part 2. In the part 1, IS 875 talks about the dead load, and in part 2 IS 875 talks about the various kind of imposed load that should be considered while designing of any steel any structure, any civil engineering structure. Okay. Also, though imposed load contains snow load, but snow load is not considered in part 2 of IS 875. There is dedicated part of IS 875 for the snow load only, that is IS 875 part 4. Okay. So, while considering the snow load, we will focus on the IS 875 part 4. Okay. We would not be require these codes, because in most of our questions or most of the problems which we will deal during this course, in those problems the values of dead load and the imposed load or snow load, crane load, all kind of load will be directly given to us. Okay. So, now let us talk about the wind load. What is wind load? We see some people may consider that wind may not affect that much, or wind may not have that much significant effect on any structure as a load. Okay. Let me tell you that wind, there are so many structures which get deformed very badly because of this wind load. Wind has very high power to deform or to destruct or even collapse our structure. Wind load is that much significant. Okay. So, how this wind load acts, how this wind load works. Okay. For example, there is a structure and there is a wind blowing from this direction. Okay. So, what this wind will do? This wind will try to deform our structure, or this wind will try to push our structure in this direction. Okay. So, if our structure is big enough, if our structure is wide enough, okay, then this force would be very high. Also, if the velocity of the wind is very high, then the force coming on this building will be very high. Okay. This velocity will depend on the various factor. Okay. Let me not go into that direction right now. One may notice that while talking about the wind, I am just focusing on the horizontal level, on this very level. Why? Because this will only cause the destruction or the deformation in the building. If wind is going in that direction, then this will also cause deformation and destruction, but the deformation or the destruction will be because of not this component, will be because of the horizontal component of the wind. Okay. So, while talking about the wind load, we consider about the horizontal component of the wind, or the force exerted by the horizontal component of the wind. Again, in the second point, what I discussed, I told that dependency of this force that is coming on the structure because of the wind will depend on the velocity of the wind, how fast wind are blowing in. For example, there is a storm going out. Okay. So, in that storm the wind forces will be very high. If there is a normal breeze is blowing, then in that case the force because of the wind will be lesser. Okay. So, velocity of the wind will increase. As the velocity increases, the wind force will also increase, and then the shape of the building, bigger the building, more the force, smaller the building, lesser the force. Okay. Then the location of the building. Okay. Location also matters. For example, there is a building and there is a big mountain in front of the building. Then on this building, the effect of the wind from that direction will be very less because of the positioning of the mountain, because there is a obstruction in the path of the wind. Okay. So, location of the building also matters a lot. As we discussed that there is a dedicated code for the dead load and the imposed load, in the same sense there is also a dedicated code for the wind load as well. It is IS 875 part 3. Okay. Now, let us talk about the designed wind velocity. Okay. This particular topic definitely contains question, a problem, okay, which we will discuss by the end of this module, or I think around in 7th or 8th lecture of this lecture series. Okay. We will try to calculate the wind pressure on a some building. Okay, we'll cover that problem in our later lectures. Okay, so let me give you a glimpse how we will going to perform, or how we will going to calculate the wind load that is coming on the building. Okay, so to calculate the wind pressure on the building, we must know the velocity, okay, or the design velocity on the building which is going to impact. Okay. So, to calculate the design velocity, we must know the basic wind velocity. Okay. What is design wind velocity? From this equation we can see that design wind velocity, that is Vz, is proportional to the Vb. Vb is what? Basic wind velocity. The value of basic wind velocity will be given to us in the questions, and there are some coefficients in this equation we can also see. There is K1, K2 and K3. K1 is basically indicating the risk, okay, how risky that load for the building, also how risky that load can be for the building. Okay. Then K2 indicates the coefficient based on the terrain, height and the structure size of the structure. Okay. K2 combines the effect of all these three parameters in this equation. Okay. Then talk about the K3. K3 incorporates the effect of topography, okay, while getting the design wind velocity. Okay. So, if we somehow calculate this Vz by knowing this K1, K2, K3 and Vb, we can calculate directly putting into this equation the design wind pressure. Okay. So, this will be the pressure through which we will design our structure. For example, there is a building and we will get this value of Pz. Okay. Okay. So, this kind of a structure we have already designed in our structural engineering courses. Okay. So, if we are provided this value of Pz, we can easily design this kind of a structure. Okay. So, we will deal with one problem in the later part of this module and try to calculate this value of Pz or the wind pressure. Now, let us talk about the another kind of a load, that is the earthquake load, which we must consider while designing of any structure. Okay. So, what is earthquake load or how does it work? We all know that earthquakes is the reason or earthquakes occurs because of the movement of the tectonic plates. For example, there are two tectonic plates, and because of this sudden movement there is a shock wave appears, and which that travels through the surface of the earth. Okay. This shock wave is basically a form of energy. Okay. What is moving in the form of shock wave? The energy is moving, okay, in the form of shock wave. And when this shock wave, for example, there is our building, okay, and it is fixed over here, and this is earth. This shock wave is moving like this. Okay. I am not drawing this in that manner in which I should be, but for understanding purpose, let us say that this shock wave transfers its energy whatever comes in the path of the shock wave. In this case, our building is coming in the path of the shock wave, and this shock wave will transfer its energy to the building. And if our building would be able to absorb this energy, if our building would be able to dispose or completely effectively absorb this energy, then there would not be any destruction. Okay. So, somehow we have to design our building to absorb this energy. Okay. So, this is not very much into the domain of our this particular course. It will be discussed in different courses like earthquake engineering and all. Okay. So, we will not go into much deeper into that. Now, let us see what our code says about the earthquake load. Our code says that the earthquake shocks can cause movement of the foundation. We can see that from this example, very example, that in another point that the total vibration may be resolved into 3 mutually perpendicular directions. Okay. That shock wave that is coming and that is striking to the building will definitely have two components. For example, let us say this is x component, this is y component, and there will be a z component. Okay. So, that z component will be in the upward direction against the gravity, and x direction and y direction will be in the at the horizontal level. So, while designing the structure or while considering the earthquake loading, we focus more on the x energy along the x axis and energy along the y axis rather than the energy along the z axis. Why we do that? Because what this z axis is doing, this z axis is doing that if it is in upward direction, then it is reducing the weight of the structure, and if it is downward direction, then it is increasing the weight of the structure. And we have already designed our structure for the dead load and for the downward load, but we generally do not go for the horizontal kind of a loading. Okay. So, the more impact will be because of x component and y component. Therefore, it is advised to resolve the total energy or the total force into 3 mutually perpendicular direction. The response of the structure to the ground in the let me read about the third point. The response of the structure to the ground as a function of the foundation, soil size, and the mode of the construction, and the duration and the intensity of the ground motion. Duration and intensity basically indicating that total amount of energy that is being transferred from the earthquake to the building. Okay. And but obviously we can really understand that the response or the vibration or the effect of the structure because of this earthquake loading will be a function of type of the foundation, soil, which kind of a soil we have, which kind of a structure we have, or which the mode in which we have constructed. Okay. As we have seen that there are various dedicated codes for the different kind of loadings, therefore, there is also a dedicated code for the earthquake loads as well. Also, in this code there are mainly two methods which are focused for the design for the computing of the seismic forces. First is the seismic coefficient method and second is the response spectrum method. Okay. Now, let us move to the erection effect. What is erection? So, erection effect or the erection loads are that load. For example, there is a construction is going on and there is a storage material, there is a construction material which is being stored in the building. So, we generally when we design we go for the dead load that is coming on the structure, we go for the imposed load, live load coming on the structure, but while construction the dead load coming because of the storage of the construction material, cranes and other erecting equipments. Okay. So, the weight because of that or the load that is coming off because of the storage and the occupancy of those material comes under the erection effect. So, in clause number 3.3 our code says that all loads that proper provision should be made for the storage of such material or the construction equipments. Okay. So, these are the few provisions which are mentioned under the clause number 3.3, that proper provisions shall be made including the temporary bracing to take care of all the stresses developed during the erection. In the other point that our code says that dead load, wind load and also such part of the live load as would be imposed on the structure during the period of the erection shall be taken as acting together with the erection load. For example, if you are constructing the building, it is a halfway done and if you are putting some construction material over there. So, while analysis of this part or the under construction part, you must consider the combinations of the dead load, live load, wind load and this erection load as well. Okay. In the last part, we see that the structure as a whole and all parts of the structure in conjugation of to the temporary bracing shall be capable of sustaining these load during erection. Your building is under construction, therefore, there will be some temporary supports that would be provided. So, these temporary supports must be able to support the erection loads. Okay. Now, let us talk about the temperature effects. This is a very important from the designer point of view in any steel structure, mostly in the steel structure. As we all know that steel is very susceptible or very much affected. It can be easily affected by the increase or decrease in the temperature. For example, let me draw this here only. Okay. There is a beam and there is a column, these all are made of steel. If we will increase the temperature of this system, then or increase the temperature of this beam only, then this beam will try to expand, and while expanding, this beam will produce some force on this very column in that direction, and because of this excess force, okay, there will be a moment, okay, on this column. So, through this example we can see how this increase in temperature is incorporating some forces in our structure. So, there are various places in India also where the temperature variation is very high. For example, if I talk about the Lucknow only, or in the northern plain of India, we can see there are many places that the temperature may go up to 45 degrees Celsius in summer only, and in winter, during winter night, the temperature may go up to 0 degrees Celsius. Okay. So, this huge variation will definitely cause this kind of a problem, and while designing any steel structure, we must consider that various temperature effects and these different forces which will come into the picture because of the temperature. So, there are few points which are made under clause number 3.4. Let me read this. That expansion and the contraction due to the change in temperature of the members and the elements of the structure shall be considered, and adequate provision made for the such effects. Okay. In the second point, the temperature range varies different localities under different diurnal seasonal conditions. Okay. Depends like in example what I said, that there is a huge temperature variation in the winter, in the summer also. Also there are so many places in India, okay, where the temperature variation is so huge, is very large in the day only. Okay. During the mid or during the afternoon, there is a very high temperature, and during the late night or in the night, the temperature drops at a very low level. Okay. So, in those region we have to the frequency of these stresses coming or going will be very large. Okay. The let me read the next point. The range of the variation in temperature of the building material may be appreciably greater or lesser than the variation of air temperature. Okay. So, what does this point is indicating? This point is indicating that we must consider the temperature difference between the air surrounding and the building. Okay. Temperature and is influenced by the condition of exposure and the rate at which the material composing the structure or absorb or radiate heat. Okay. It is very much clear to you. In the next the last point, it is indicated that we must consider that effect also when for example, there is a room, and in your room there is a AC, and the outside surface of the beam will be subjected to direct sunlight, direct heat. Okay. So, this temperature variation will definitely cause some stresses in the structure, and while designing any structure we must consider these kind of a things also. Okay. Now, let us talk about the various load combination which are suggested by the IS code under clause number 3.5. So, in load combination IS code says that we do not design building by targeting single load. We do not design building by targeting some other load only. Okay, we design building by combining the effect of all these loads and picking out the severe most combination. Okay, that combination which is causing the most stresses in the building, through that stress value we design our building. Okay. So, our IS code says that the load combination for the design purpose shall be those that produce maximum forces and effects and consequently maximum stress and deformation. Okay. Following combinations are appropriate and partials are used with appropriate partial factor of safety. Okay. IS code suggests following combinations and says that use this combination with appropriate partial safety factors. Okay. In first combination there is a dead load and imposed load. In second combination there is a dead load, imposed load, wind or earthquake load. In third, dead load, wind load or earthquake load, dead load and erection load. There are two things to be observed, that dead load is always there, dead load is always there means there would definitely be a dead load, and there is one more thing to be observed, that wind or earthquake load means either wind or earthquake. I will discuss it about in our next lecture. Okay. Let me stop it here only, and we will go through this again in our next lecture. Okay. Thank you.